It's Harish from Motorola Solutions. I'm a principal architect in Advanced Technology, Unified Communication Group in Motorola. I'm going to talk about how we have leveraged Apache Ignite for our next generation multi-site deployment architecture. I will introduce a few topics in that regard. What we are going to cover today mainly how it was our architecture before, what we need as a new generation of architecture for our platform and our solution, and how Apache Ignite is helping. These are the topics we'll cover today. At the beginning, just want to give you who we are. So Motorola Solutions is a leader in public safety communication. We provide various mission critical communications services solutions for public safety enterprises and in the critical communication mechanisms. Basically, you'll hear a term called mission critical communication when you introduce service for public safety. So what is a mission critical communication really? Mission critical communication is really ability to provide a reliable way to communicate when the moments that matters for the people who is in need. So when there is a disaster, when there is an emergency, so there is a need for communicate, establish effective communication, provide intelligent information to the public safety people as well as for the public. So that's a mission critical communication solutions really about. So there are different kind of deployments, customers. There is on premises, which is on site data center kind of deployments. There are cloud deployments, whether it's Azure, Amazon, and so on. And there are different kind of customers. It could be very large operators like AT&T, Verizon, or any of these large scale operators in the world, or it could be very small operators with, like, let's say 100,000 users or 1,000 users, or it could be an enterprise. So there is a different kind of customer base we support. So in this mission critical environment, there is certain requirement for the software platform. When we develop a software, there are certain things we are depending on underlying software platform. So most important things, there's a couple of key points to be in this mission critical communication environment. Number one is that high availability. What is high availability? High availability means your service is available all the time. So there is a criteria for measuring it. So it's like we call it as 5 nines. 5 nines means 99.99% of the time it is available. That means the entire year you can be down only for 5 minutes. For whether it's for upgrade, maintenance, doesn't matter. So that's the kind of requirement we need. And we are moving towards zero downtime. So that means that downtime needs to be zero. So it needs to be no downtime when for whatsoever reason. That's a goal. Then is a high reliability. High reliability is consistent services, quality is not degraded. You always have the best, no breakage in voice, for example, and all the time, all the information is available for our customers. High reliable services. Then another important aspect is for database perspective, a low latency queries. Why is important for us? Because our communication involves large set of users. Sometimes it's like several thousands of users connected over a group call. So and that call setup has to happen within like seconds, milliseconds. And if there is a emergency communication happening, for example, imagine there is a case for a chase, emergency chase is going on. Police is chasing somebody, or another emergency situation happening. So the need for communication is instant. So there is like within a second, usually it is like less than a quarter of a second, the call communication needs to be established, and is very stringent. And other similar communication mechanism also exists. It could be a messaging communication, or it could be video, all those kind of communications. But in that, most important, what you'll hear is a push to talk. Push to talk is where you need to connect public safety users instantly. So that is where the low latency for database comes into picture. Then there's high scalability. So scalability, we need a flexible scalability solution where we can scale from few thousand users. For some deployment, you have few thousand users, and some deployment with the millions of users. So, and we need a mechanism, we need a capability where you can scale from start with a few thousand users, then you can scale it up to millions. Okay, so what are we looking at as this new our target architecture goals? So along with that, so we are looking at active architecture. So we want all our services, application services, to be running in the active mode. We we want to move away from our traditional active standby mode, where to do when a particular server failure happen, there is some kind of switchover that requires certain uh, certain outages or certain period for recovery from one side to another side. So rather, the new direction is we want to do active architecture. Then I talked about flexible deployments where you can scale from small to large. Then third is elastic scalability. Elastic scalability means you can start with a few servers, then you can keep on adding more servers for your for capacity reasons, or it could be a spike of the service. For example, there is a season where there's a more number of subscribers, users comes in, there's a need for respond to your services. So you should be able to scale your application services dynamically. So then what we from the data layer perspective, we want a automatic self-managed data replication framework that can take care itself without a lot of intervention from the operations or maintenance perspective. So then another aspect what we need is automatic recovery. So what happened when to provide a geo-redundancy at 5 nines level, you really need to provide it via multiple data centers, which are typically spread across two different geographical regions. So in that this situation, what happens is it's possible that some IP connectivity problem happen. There is obviously your communication depending on certain type of the IP communication, whether it's a VPN or dedicated circuit, whatever. So in that situations, what you can have is there could be interruptions. So sometimes that can be quick. So sometimes it could be longer. So in those situations, we need these frameworks automatically take care of that kind of situation and recover it. So by have all this capability, we really want a zero downtime capability where if you want to upgrade whether it's application software or this database platform, it should be done in like rolling upgrade fashion without without the need to bring down any service nodes, any database nodes in that process. So how we have achieved using GridGain? So basically, we have used Apache Ignite as a core software for to achieve this at database layer. We are using Apache Ignite as a distributed in-memory cache. We are so there is a this model provides how that looks like. So this provides this kind of with the GridGain version being in, it provides inbuilt mechanism for data replication, reliability, and scaling. And it also provides something called near cache, so where you can use it for optimizing low latency queries within application server. And we can also the built-in SQL capability is very useful for porting your legacy application, which is already familiar with which is already using the SQL interfaces. So I'll talk about that again in the next slide. So before getting to the more details on the new architecture, I'll just talk about how we do it, how we did it before, right? How we have provided solution so many years. So we have been in the market and we have been providing similar solution. How we have provided it? So traditionally, we have any RDBMS you take it today. They are SQL based databases, or there could be other type of databases, whether it's a key value or other type of databases. But primarily, to achieve the kind of scalability you need, there's certain aspect you have to take care. So, so it starts with the model where you will have something, you will have a central repository where all these you will be, it will be, you can call it like master database where you will be storing entire data of your deployment there, and you start providing redundancy for it, and then you can start making a copy of that to the wherever you want to serve customers or serve subscribers. In this model, what I can show you showing here is you can see here in the top the data management layer where service request comes in to manage the data, customer data, whether it's, let's say, you are adding a subscriber information, let's say it's a subscriber's name, or adding a list of users, or whatever data management operation could be. So you serve that to the central database and you make it as a read write, and then you start creating copies wherever you want to make it in the other data centers. So that's where you'll run the application services. So this is a kind of model you can use to scale it up to millions, because basically you can make it make the data available across regions. You can make this data center 3 and 4 in this example spread across northwest region, east-west region, and so on. Like you can spread it across all around the country or worldwide as you need. And but whereas your data management may be centralized. So this could be on model we could use with your legacy RDBMS database replication. Now, how do you, if you have that, how do you make sure that data is replicated across all these database nodes? So for that, what you do, you can set up a replication. So typically you will do that by setting up replication from one node to another node, whichever there will be source node and there will be target node, whichever data you want to replicate, and whichever data center you want to, you can set a replication. In our model, what you have done is there is a central database, and we replicated that data into all other edge data. You can say edge data centers where our service, wherever you are serving the customer service data centers, one-way replication, so that we can do all this data management in a central node, whereas services are using that data in the edge nodes. So how we can do the scalability? So in this model, you just keep adding more nodes, then you can set up a replication for that. So you can keep scaling this kind of model as long as you have enough memory in the central database. So now, how do you provide a redundancy for the central database? So just have one more node, one more similar, identify another data center geographically separate and replicate data from your one central database to another database, another data center. So it's simple as that. So then what is the problem? Why you can't keep using that model forever? A lot of challenges. What challenges? First of all, every time you want to do an upgrade, it's a traditional database. It's not flexible. So it's an older database model. It's very hard to change schemas when replication is involved. So when you change a database schema in one of the central database, for example, then that means we need to make sure that all the service nodes across all different data centers knows about that. They are prepared to accept the change. So that is a much bigger challenge. So you need to do the application upgrade, application ready to accept such changes before you make changes in the data. So think about now designing that. So that means you need to design your application when you design your application, you have to keep that in mind. Okay, So database going to change from another data center. I need to make sure that it's not going to impact my application. So then you have scalability problem also. So you can scale central database to some extent as long as there is a memory and resource are available. In our case, one point I have to note down is for us, in-memory aspect of the database very important. As I said, we need to have a certain SLA to meet to on the call setup time that requires very low latency. So we cannot afford to have the data in the cold storage or hard disk or SSD and accessing it. We need a solution where any required data is immediately available in memory. So here, one of the challenges we are facing is how do you scale this? When you keep scaling the central database, we keep adding memory. So memory was not a problem because every 2 year memory size keep doubling. So we could accommodate a lot more subscriber as it memory went in. But when you added the new services, when you needed even more space, it start become a problem. We couldn't accommodate it, so this become a problem. So management node at memory, we have to find a solution for that. Then another problem, so these databases are not designed for tolerance for IP failure. So when there is an issue, then replication data will be getting backlogged, and it will take long time for recovery, and it many times requires manual intervention to to retrieve a backup, apply it, and restore it. So it was not very automatic. So that's where we found Apache Ignite. So Apache Ignite based with the GridGain enhancements, we saw that we can lot of database layer, data cache layer problems are already addressed by this Apache Ignite GridGain solution. So that was we found that as a one best fit. So that provides local cache to access the memory. There's any optimization required for the application. It also allowed us to port our existing SQL application, and it allowed us to do scale horizontally instead of the vertical scalability problem we had with our previous model. So we can scale it horizontally now at database layer, and that automatically provided reliability scaling and most importantly multi-site data replications. So with the GridGain, we are able to do not just 2 data center as before. We could go even higher number of data centers, and we could replicate only data what we need as well. It's not like everything in data center 1 needs to be replicated to data center 2 or 3 and all the data centers. We can be selective. You can decide, okay, corporation enterprise once data stays in data center 1 and 2, and another corporates can go from data center 1 to 5 and so on. Or it could be different type of application. Let's say it's a messaging application, then that's maybe served by 5 data centers, whereas voice PTT application may be served by all 10 data centers. So that model is possible with the GridGain's replication architecture. So in a whole, it really allowed us to scale our applications horizontally as well as data layer horizontally. It really enabled us to start introducing those kind of capability into our platform, and thus start moving towards migrating from our existing architecture to the new target goals what we have put forward. So these are some of the key database capability which we are leveraged. There are a lot more, and there are a lot more speakers who will talk about a lot more features, of course. But some of the features directly impacted us is this in-memory caching and concurrent information and multi-node replication, multi-data center applications. Then JDBC SQL interfaces. So along with this comes with the key value, built-in key value information, key value access to the database where you can access same data using key value as well as SQL, and various tools and procedures supporting this operating GridGain clusters, Apache Ignite clusters. These are a couple of points here which we found not exist. It doesn't exist in traditional database, RDBMS databases, which we have took benefit in our new architecture because of the Apache Ignite. So one is of course the original goal here, active architecture. Then flexible memory caching. We can have a subset of data cached, subsets on other data which we want that data to be in cold storage. We can keep it in cold storage. That this model, this framework allowed us to do that. Then scheme upgrade. So it made our upgrade design very simple. Application side and even database layer side. Schema changes very simple. It made us operationally efficient. And multi-data center application, it made it more robust. So basically, itself will take care about built-in solution that takes care of storing that unreplicated data locally until the IP connectivity between data center recovers. Then gracefully start applying it back into the wherever that change is not propagated. So that multi-data center, very robust solution, allowed us to deploy our application across multi-data centers. And there is a lot of, we are still experimenting with this deployment automation. There is APIs available which we are planning to take leverage when to our applications. Then, of course, it comes with the cloud platform, native cloud platform support such as Docker, VMs, Kubernetes, so on. And these are the key points, really, what really help us enable our new platform for Motorola Solutions Unified Communication product line. Thank you. So if you have any questions, you can type it and I can address it.
Thank you, Harish. So,
hi.
Welcome back to the stage. Hi. So, thank you for that. We've got a couple of questions for you. So, I'm going to dive right into those. So, the first question we have is, how do you handle IP or WAN connectivity link failures between multi-data centers? And is the data sync between the data centers automatically? Because this is obviously very high availability. You've got very high standards. So how do you handle that kind of failure?
Yeah, I kind of covered a little high level in my presentation, but here really a good part about GridGain is it itself has a built-in replication mechanism where it knows what has been not replicated and start storing the data, and then it start applying it when the IP connectivity is restored. But there is a we primarily depending on Apache Ignite and GridGain framework to do this data synchronization. But there are some cases, I mean, when the data size grows quite big, right? Let's say outage is several hours or several days. So there may be a situation you might have to apply it manually. There is something called DR kit or disaster recovery kit where you have to apply these changes. But more or less on the smaller scale or to certain degrees, automatically handled by Apache Ignite layer itself. So,
okay. Have you used Apache Ignite in multi-data center configuration in production? And is there any experience or feedback that you could share?
So we have currently used it in 2 or 3 data center environment that's in a production. So our intention is to scale it to multiple data centers even more. There is a need to go, let's say, 7 or 9 data center kind of uh, configuration. So it works good so far with the 3 data centers. So we are exploring what extra we need to do, and the promise is that we should be able to use this same scale to even more data centers going forward.
Okay. And then lastly, and actually this question comes from me. So tell me about customer acceptance in a situation where you have such high benchmarks of performance, zero downtime. I mean, there must be a lot that goes into testing and into proof of concept and into customer acceptance of such a high demand situation.
Yeah, I think that is really the biggest challenge for us. So first of all, we cannot keep changing the. We choose a framework for any of this our software platform. We have to stick with that for quite some time, quite many years, really. Uh, so the reason is exactly that. So it takes time to mature. Uh, just take a framework, the hot technology from the marketplace, apply it into our platform. Many times it doesn't work because we need to make sure that it works on different type of deployment environments, small to big, and also most importantly, make sure that is absolutely working in all situations. So what is our experience is really when we have this any of these third party platform, there is always something missing at the beginning. So it takes like few years to get matured. So it goes through that. What we do is it goes through the prototype stage. That's where my team involved. It is called next generation or advanced technology team, where we choose a framework, new technology. Then we evaluate. Then we involve our development team, do the prototyping, and make sure that it meets the needs. Then we kind of start integrating into certain feature in the product and make sure that it really works. Then it goes through our regular product cycles. Then we keep incrementing the feature set on the new platform and gradually replace the whatever older platform that for that function. So it takes quite some time for us and it's quite intensive.
Okay, so it's a kind of bit by bit approach.
Yeah.
Another question from Jeremy. Um, which features announced for Ignite 3 do you think are the most exciting for large scale and fault tolerant architectures? Where, did you get to catch the talk on Ignite 3 today?
Yeah, so I haven't really listened to all the features, but one thing I am excited about is the replacement of SQL engine with the call site. So this is one of the things we have been asking Apache Ignite and GridGain on the SQL syntax, right? SQL capability. While it has a lot of capability today, and there are quite few things missing as well. So those things promises that Apache Ignite 3.0 will kind of fix it. I mean, it adds those capability. So that's really the most important thing. And another thing really is more of hidden inside the framework itself. Basically, some of the stability or some of the robustness issues within the uh, Apache Ignite itself. So, for example, a distributed cache, I mean, there's a dynamic cache replication and those kind of features was not that stable. So, I think the promise of some of this re-architecture really going to help us on that, making it more reliable, more robust from that perspective.
Okay, and then what I think is our last question, and might even be the last question of the day. Um, what kind of Ignite component failure modes do you routinely test or recommend for zero downtime designs?
So basically, we use a mode where it's data is sharded across multiple nodes. within the clusters, and there will be a, clusters for each data centers, separate data Apache Ignite cluster for a data center one. There is a similar another cluster in the data center two, and so on. And we use data center to data center application, that sender receiver node built-in solution to replicate data. So then also we use this thick client and thin client thing. So thick client provides this near cache solution. That's quite useful, and but it's a little bit memory heavy and processor heavy. So we are there is wherever we don't need that kind of optimization, we use the thin client. And this thin clients, this the built-in client uh, has a mechanism where they can connect to any of the nodes in the cluster automatically, and we can even enhance it to make that client to connect to another data center when the one of the primary data center wherever application is connected is not available. So those are the kind of design we do, and what we do is we use Apache Ignite GridGain as a base, so it provides a lot of built-in features and functionality, and we build it over it, and we add more capability to make it reliable for our platform. So, for example, if we use continuous query to even to get a callback on cache data to make sure that any of the application cache can get updated information and so on. So it's quite useful. Yeah.
Great.
And another most important thing I need to add is for zero downtime, right? One of the key important factor is the rolling upgrade. So that is the one assurance we have from Apache Ignite GridGain, that any of these major releases or any of these things, there is always a guarantee to have a rolling upgrades. So you can upgrade entire cluster without bringing down cluster. So that's one of the key thing looking from the what is useful from the GridGain Apache Ignite.